Hello everyone, in this video let us solve this question. So we have t raised to power t is equal to t raised to power 3, and here we have to solve for the value of t. So t is the unknown we have to solve for. To do this solution, we have t raised to power t is equal to t raised to power 3. By working with this rule, that if you have a raised to power b equals a raised to power c, since they have the same base, compare the exponent b is equal to c. So applying this rule right here, we can all conclude that since they have the same base, the value of t is equal to 3. Alright, good. Quite alright, this is one of the values of t, but there are other values for the solution of t. So let us solve them. So the first thing we're going to do is to divide the equation with t raised to power 3. So this becomes t raised to power t over t raised to power 3 is equal to t raised to power 3 divided by t raised to power 3. Such that with this, what we have is t raised to power t over t raised to power 3, okay, is equal to, this divide this, we have 1. Now, following this rule of indices, that if you have a raised to power b over a raised to power c, this equals a raised to power b minus c. Applying this rule right here, this then becomes, we have it as t. Since we have the same base, you pick one, then you subtract the powers. So t minus 3 is equal to 1. Then at this junction, we are then going to introduce natural logarithm to both sides of the equation. So ln t raised to power t minus 3 is equal to ln 1. From here, applying this rule, that if you have ln a raised to power b, this equals b times ln a. Applying this rule right here, t minus 3 comes over to this place, and then this becomes, in brackets, t minus 3 multiplied by ln t is equal to ln 1. With this, the value of ln 1 is equal to 0. So here is equal to 0. This becomes, in brackets, t minus 3 multiplied by ln t is equal to 0. Then at this junction, we can equate this to 0 or equate this to 0. So we have t minus 3 is equal to 0, or ln t is equal to 0. So for this first equation, that we have t minus 3 equals 0, move minus 3 over to this side. The value of t is equal to 0 plus 3, such that the value of t is equal to 0 plus 3 is 3. And this was the initial value of t that we got initially. So, but then the other value of t from this other equation right here, that we have ln t is equal to 0. To solve for t, we need to remove this ln from here, and to do so, introduce e. So e raised to power ln t is equal to e raised to power 0. With this, e will cancel ln, t is equal to e raised to power 0. From here, the value of t is equal to e raised to power 0 is 1. So we've gotten the other value of t. So t2 is equal to 1. So therefore, we only have two solutions for the value of t. t1 equals 3 and t2 is equal to 1. But then, let us confirm if the solution of t are the correct solution for the question. So the question, which is t raised to power t is equal to t raised to power 3. For t1, which equals 3, inputting the value of t as 3, so t is 3, raised to power t is 3, equals t is 3 raised to power 3. So since they are equal to each other, this means that the value of t1 as 3 is the correct solution. Okay, what of t2, which equals 1? So testing that one out, we input the value of t as 1, so t becomes 1 raised to power t is 1 equals t is 1 raised to power 3. 1 raised to power 1 is 1 equals 1 raised to power 3 is simply 1 in 3 places, 1 times 1 times 1. So 1 is equal to 1 times 1 times 1 is still 1. So with this, since they're equal to each other, this means that the second value of t, which equals 1, is also the correct solution. So this means that the two solutions that we got are the correct solution of t. Good. So with this, I hope you all enjoyed the video. Don't forget to like this video, subscribe to this channel. Thanks for watching. See you in the next video. Bye.